This is section 14.6 for Algebra 2 Trig, the inverse cosine and inverse sine. Today we're going to ask, how do we evaluate expressions involving the inverse cosine and inverse sine? So, to explain how this thing works, first we need to look at this graph. This is a graph of y equals cosine of x. And it's a pretty familiar graph. It's got that familiar sine wave. Now, this is a function because it passes the vertical line test. No matter where you draw a vertical line, it intersects at most only one point on the graph, which makes it a function. However, it is not a one-to-one function because if you were to draw a horizontal line anywhere on the graph, you would hit a number of points. So you can't merely take the inverse of cosine of x by flipping the x and the y. We have a little trick to do that. So the inverse wouldn't be a function, but what we can do is restrict the domain for the interval to 0 and pi, so that x is in between those two numbers. Now we have a one-to-one function. So basically we're taking this entire cosine curve and we are only going to use values of x from 0 to pi. Now why do we choose 0 to pi? Well, that's because if you notice that the value of cosine can only be between -1 and 1. And for x from 0 to pi, it will cover all the possible values of the cosine of x, all the way from 1 and all the way down to -1 with every value in between. If we take this segment and use it alone, we have a one-to-one function, because if we were to draw a horizontal line, it would only intersect the blue line at most one place. So this new blue graph is called the cosine of x with a capital C. For every number u, such that u is in between -1 and 1, there exists a unique number v such that the cosine of v is u. Now the reason we do this again is so that we have a one-to-one function, so we can take the inverse. Now what this means is there's going to be only one number from 0 to pi that has a cosine of whatever, 1/2, -1/2, radical 3 over 2, 1, -1. And you won't have multiple values, because if you take the cosine of pi over 2, you get 0. But if you take the cosine of 3 pi over 2, you also get 0. But here, in this range, or in this domain actually, only pi over 2 will give you a cosine value of 0. And this leads us into the inverse cosine function. This number v is denoted by the inverse cosine of u. This is noted with a capital C. This is not the same as 1 over the cosine of u. This is the symbol for an inverse. You will see it's also called the arc cosine or arc cos. Now, y equals the inverse cosine of x if and only if cosine of y equals x and the values of y are between 0 and pi. So, normally when we try to find the inverse of a function, we swap the y and the x and we find the inverse by solving for y. Now, the problem is here, there's so many possible values of y for each x that we need to restrict the range. So our range is only going to be between 0 and pi. The domain for the inverse of cosine and sine is only going to be between -1 and 1. If you have something like the inverse cosine of 2, you're going to get an undefined value. So the range is restricted to 0 to pi, and the domain is going to be between -1 and 1. Now if you take a look at a unit circle, you will see why we do this. Here's 0, here's pi. And from 0 to pi, it covers all the possible values of cosine. So again, your domain is going to be from -1 to 1. And the range is going to be the corresponding y value that goes from 0 all the way to pi. Now, you can get similar values down here, but again, if we go beyond these two endpoints, we are no longer going to have a one-to-one function for the original cosine, and we can't take an inverse of it because it won't be a function. Likewise, the inverse sine is denoted by y equals inverse sine of x with a capital S. Now, the domain here is different. For this, the domain is going to be -pi over 2 to x is pi over 2. Now, what's actually happening here is the domain of this inverse function is actually from -1 to 1. The range is going to be from -pi over 2 to pi over 2. So, y equals the inverse sine of x if and only if the sine of y equals x and y is between -pi over 2 and pi over 2. So again, x has to be between -1 and 1. Anything beyond those endpoints is going to yield you an undefined value of y. Likewise, the range is going to be limited between -pi over 2 and pi over 2. Those values in the range will cover all the possible values of x, all the way from -1 to 1. And if we look at our unit circle for inverse sine, this semicircle here from -pi over 2 to 0 to pi over 2 will cover all the possible values of sine. Now remember, the y-coordinate of the unit circle corresponds with the sine function. So this will cover all the possible values of y, from negative pi over 2 to 0 to pi over 2. So the graph of the inverse cosine of x with a capital C, again, the domain is only from negative 1 to 1. The range is going to go from pi all the way down to 0. So the inverse cosine of negative 1 is going to be pi. The inverse cosine of 0 is pi over 2. The inverse cosine of 0 is going to be 1. For the inverse sine of x, again, the domain is restricted from negative 1 to 1. The range is going to go from negative pi over 2 to pi over 2. So when the inverse sine of negative 1 is going to be negative pi over 2. At 0, the inverse sine of 0 is 0. And at 1, the inverse sine of 1 is going to be pi over 2. So remember those restrictions for the domain, and you won't go wrong with these answers. Number 1, the inverse sine of 1. So the book's going to do it a certain way, and you can follow along the way the book does it, or you can end up taking shortcuts later on because you're basically doing a step that you don't have to do, but it might make some of it easier for you to see. So remember that for the inverse sine, the range is going to be between negative pi over 2 and pi over 2. And remember, the domain is going to be between negative 1 and 1. Again, if you have the inverse sine of 2, you're going to get an undefined value. So the question is, where is the sine between pi over 2 and pi over 2 going to be 1? So let's call u the inverse sine of 1, so that the sine of u has to equal 1. Well, what value between negative pi over 2 and pi over 2 is the sine going to be 1? And if you look at a unit circle on your paper, you will see that's going to be at where u equals pi over 2. Remember, the sine goes with the y-coordinate. So in the unit circle, y is 1 at the very top, where u is pi over 2. So the answer for the inverse sine of 1 is pi over 2. And if you were to look at a unit circle, again, you are restricted to between negative pi over 2 and pi over 2. This is where y is 1. It's going to be at pi over 2. Number 2, the inverse cosine of 0. So again, you want to ask, where is this going to happen? And the solution has to be between 0 and pi. So that's the range for the inverse cosine. So let's call u the inverse cosine of 0. That means the cosine of u is 0. In other words, what value between 0 and pi will give us a cosine of 0? Well, that's also going to be at pi over 2, because remember, the cosine goes with the x-coordinate of the unit circle. And so the inverse cosine of 0 is at pi over 2. And if you look at a unit circle, remember, we want a value from 0 to pi. At which of those values is the x-coordinate 0? And that's going to be at the top, where the answer is pi over 2. So you can see how the unit circle helps you solve the problems if you are familiar with it. Number 3, the inverse sine of negative 1/2. So again, we can do it the long way. The inverse sine has to be between negative pi over 2 and pi over 2. That's the range of inverse sine. So let's call u the inverse sine of negative 1/2, such that the sine of u is negative 1/2. So if you were to look at a unit circle, u would have to be negative pi over 6. So the inverse sine of negative 1/2 is negative pi over 6. So remember, your answer has to be between negative pi over 2 and pi over 2. And you want to know where the inverse sine is going to be negative 1/2. Well, that's going to be at this angle right here, at 11 pi over 6 on the unit circle. But remember, your answer has to be between negative pi over 2 and pi over 2. So what measure coterminal with 11 pi over 6 would fit that range? And the answer is negative pi over 6. So that's basically going from 0 clockwise, pi over 6, negative pi over 6. So you can do it the book way. You can use the unit circle. Just remember the ranges of the respective inverse functions. Number 4, the inverse sine of the sine of 11 pi over 6. So remember, you're going to want to do the parentheses part first. So first find the sine of 11 pi over 6, which is basically negative 1/2. We just kind of did that in the previous example. So you'll have to memorize this and do this in your head or using paper. Sine of 11 pi over 6 is negative 1/2. That's 330 degrees in case you're counting. So now you need to take the inverse sine of negative 1/2. Well, we just did this in number 3. The answer is going to be negative pi over 6. So if you get a composite function like this, or composite problem, do the inside first. Figure out what that value is, and then take the inverse sign of that value, remembering that the answer has to be between negative pi over 2 and pi over 2 for inverse sine. So if you notice this right away, all you really had to do was convert 11 pi over 6 to its equivalent coterminal measure between negative pi over 2 and pi over 2, which is negative pi over 6. 5. Cosine of the inverse sine of negative 4/5. Now this is going to require several steps. Let's call v the inverse sine of negative 4/5. So this whole quantity inside the parentheses we are going to call v. So if this is true, that means the sine of v has to be negative 4/5. Remember, the inside of the parentheses here is v. Now, we can solve for the cosine of v because we can use the Pythagorean identity. So the sine squared of v plus cosine squared of v equals 1. So the cosine of v is going to be the square root of 1 minus sine squared v, which if you plug it in, gets you the square root of 1 minus the negative 4/5 squared, which is either going to be plus or minus 3/5. Now, the question is, how do you know if it's positive or negative? Well, since the sine of v is negative, it must be in quadrant 4. Remember, the sine of v is negative 4/5. This whole thing is v. So since it's negative, and remember, the range of the inverse is between negative pi over 2 and pi over 2, which means it's either a quadrant 4 or quadrant 1 angle. This measure of this angle has to be in quadrant 4. So that means if the sine of v is negative 4/5, the cosine of v is positive 3/5, which means v is the inverse cosine of 3/5. So let me repeat that. This whole thing is v. We came to the point where cosine of v is 3/5, which means v is the inverse cosine of 3/5. So now we can substitute that in for v. So v was the inverse sine of negative 4/5. V was also the inverse cosine of 3/5. Now that we have this problem, this is very easy to solve because by the definition of the inverse, the cosine of the inverse cosine of 3/5 has to be 3/5. Why? Let's call again v. The cosine of v is 3/5. So we know that the cosine of v is 3/5. This will look clearer when we look at number 6. You could also think of this as a right triangle. If the inverse sine is negative 4/5, you have a right triangle with a hypotenuse in the fourth quadrant of length 5 and a y-coordinate of negative 4. From there, you can calculate the x-coordinate, which is 3. So then you can kind of see what the cosine of that angle is that makes that right triangle in the fourth quadrant. Number 6, the cosine of the inverse cosine of 6. So let's again call v, the part in the parentheses, the inverse cosine of 0.6. We can rewrite that such that the cosine of v is 0.6. All we're doing is rearranging the parts of this equation. Cosine of v is 6. Well, that's what we're solving for because this part in here we have called v, and we just showed that the cosine of v is 0.6. So by the definition of inverse cosine, the cosine of the inverse cosine of 0.6 has to be 0.6. Finally, number 7, the inverse sine of the cosine of negative 5 pi over 6. So the first thing you're going to have to do is calculate this by its exact value. Once you get this, take the inverse sine. If you want to go ahead and try this one, you may. Alright, so the cosine of the negative 5 pi over 6 happens to be negative radical 3 over 2. This is a third quadrant angle. Cosine is negative in the third quadrant. Reference angle of pi over 6 are 30 degrees. So the cosine of negative 5 pi over 6 is negative radical 3 over 2. So if we substitute in negative root 3 over 2 for this, we are looking for the inverse sine of negative radical 3 over 2. Now remember, the range for inverse sine has to be in between negative pi over 2 and pi over 2, which means this is not in the correct range. This is beyond the range. So we have to find the value where this inverse sine is negative root 3 over 2, and that happens to be at negative pi over 3. It's going to be the answer is going to be negative because this is negative, and thus we're in the fourth quadrant. So where is sine negative root 3 over 2? At negative pi over 3, or the equivalent of 60 degrees. So inverse sine and inverse cosine are not complicated. Just remember that the range of the inverse of each function is different. For inverse cosine, your answer is between 0 and pi. For inverse sine, your answer is between negative pi over 2 and pi over 2. And you can do those substitution tricks to solve these composite problems. That's it for 14.6. If you have any questions, please ask me during class, email me, or post a note on the Facebook page.